This video is about percent composition. So as you can see, the definition here says the percent by mass of an element in a compound. So if you look at this diagram over here, we have K2CrO4. So there's three different elements: potassium, chromium, and oxygen. And if we look at this pie chart, they look to be all in about equal percents by mass. So what does that mean? If we look at something like H2O2, right? There are 4 atoms total. So 2 out of 4 are hydrogen, which is about 50%, and 2 out of 4 of them are oxygen, which is the other 50%. So this would be by atoms, but our definition is by mass. So if we look at the mass of hydrogen on the periodic table, that's 1.008, and the mass of oxygen on the periodic table is 16. So with such a large difference in mass, my percent composition by mass is not going to be 50%. Oxygen has a much bigger mass, and since there's 2 of them, it will make up about 95%, and hydrogen will make up about 5% by mass. So notice the big difference in my definition plays. So we're going to use this equation here that says mass of element divided by mass of compound times 100 to get a percentage. So we're going to use the molar mass calculations that we've been learning, plug our values into this new equation, and be able to calculate the percent composition of a compound. So if we look at some examples, it says calculate the percent composition of each element in the compounds below. We'll do just a couple. So if we start with number 1, which you should also be able to see shown on the board in class, we have NaOH. So NaOH, which is sodium hydroxide, is made up of 3 different elements. So the first thing I'm going to do is calculate the molar mass. So I have sodium, oxygen, and hydrogen. There are 1 of each element in this compound. I'm going to multiply each one times its atomic mass from the periodic table. Now since I have 1 of each, I don't actually have to multiply. I can just skip straight to adding these up. And if you do so, you get 39.998 grams per mole. So this is the molar mass of this compound. Now, if I want to use this to calculate the percent composition of each element, I can say, well, the percent of sodium is going to be equal to, go back and look at your equation, the mass of the element, which in this case is sodium. So our mass of sodium is 22.99, divided by the mass of the compound. So that's my molar mass down here, 39.998. I multiply my answer times 100 to get a percentage. So on your calculator, you take 22.99 divided by 39.998 times 100. Round a little bit, we get 57.48%. So that's just 1 element, but I have 2 other elements, oxygen and hydrogen, so I can continue this process for the others. So if I want to know the percent of oxygen, right, I'm going to use my same equation here, mass of element, except now I have a different element. So now I'm going to use the mass of oxygen, 16.00, divided by the mass of my compound. Well, I have the same compound, so I have the same mass. Times 100, so that I get a percentage. And when you put this in your calculator, you get something like 40%. Now I have 1 last element left. And because it's the last element, I can go about this 2 different ways. I can set everything up the same way I've been doing, or I can think to myself and say, well, all of these percentages should eventually add up to 100%. So if I take 100% and subtract both of my current percentages, I should end up with 100 minus 57.48 minus 40 there's 2.52, I'm sorry, percent remaining. And if I set all of this up the same way, where I take the mass of hydrogen divided by the mass of the compound times 100, either way you should get the same answer. Okay? So let's look at one more example. Number 2. Al2 SO4 3. So this one looks a little bit more complicated because now there's parentheses. I don't just have one of each element. So still, I'm going to start by finding the molar mass of this compound. So I have aluminum. There are 2 aluminums. Sulfur. Remember your parentheses, so the 3 distributes to everything inside the parentheses. So 1 sulfur times 3 is really 3 sulfurs. 4 oxygens times 3 is 12. So I multiply each of these times their mass that's on the periodic table. So 26.98, 32.06, and 16. So 2 times 26.98 equals 53.96. 3 times 32 is 96.18. And 12 times 16, 192. So I add all of these together. Get 342.14 grams per mole. So that's my molar mass, the total mass of the compound. So now, remember, I'm going to go back to using my equation. Mass of the element divided by the mass of the compound times 100. So if I want to find the percentage of aluminum, I'm going to take the mass of aluminum divided by the mass of the compound. Well, notice now I have 2 aluminums. So 2 times the mass of aluminum gives me a total mass of 53.96. That's the value I use for the mass of aluminum, not the value on the periodic table, because there's not just one, like in my first example. So if there are more than one, you should use the total amount of mass for that element, divided by the mass of the compound, times 100. Put that into your calculator. You can see over here off to the side, 43.96 divided by 342.4 times 100. 15.77%. Now look at the percentage of sulfur. Using the same equation, the only thing that changes the number at the top. Different element, different mass of the element. So now I'm going to use 96.18 because that's the total mass of sulfur divided by the same total mass of the compound times 100. 96.18 divided by 342 times 100, 28.11%. For my last element, I have the choice to set it all up, or remember that all 3 should together equal 100%. 100 minus 15.77 minus 28.11 means that oxygen must have a percent composition of 56.12%. Now, keep in mind, this only works for the last percentage. So if your compound was made up of 2, once you found the first one, then the second one you could just subtract 100 minus that one to get the second percentage. But here, since there are 3, I have to do the complete calculation for the first 2, and then 100 minus each of those should give me my last percentage. If there were 4 elements, I would have to do 3 calculations, and then the fourth one, the last one, is the one where I can take 100 minus all my other percentages. So that's percent composition, and you should be able to complete your assignment here now. Be careful because the top half says calculate the percent composition of each element in all of these. So for every element, just like we did in our examples. But the bottom half says to calculate the percent composition of only one particular element in these compounds. So you should find the total mass, but you'll only perform 1% composition calculation for the element shown. Okay?